Alright guys, so let's take a look at the chapter 11 overview. Alright guys, so let's look at chapter 11 overview, understanding randomness. While reading chapter 11, keep these objectives in mind. These objectives are things you should have learned about. It's not easy being random. Random numbers, pseudo-random numbers, which are like fake random numbers or false random numbers. Practical randomness, simulations and trials, building a simulation component, response variable, and modeling your simulation. TI generating random numbers, and what can go wrong. Here's some videos. As you can see, not all of them are filled in because they're still saving and uploading to YouTube, so it'll just take a while for me. Here's some links. That first link, Patrick Dooley D High School, DHS, I'm guessing it stands for high school, has all the chapters for AP Stats actually, and like some other teacher did that stuff. So you could go to that, or you could go to Quizlet, and it'll cover chapter 11, 12 AP Stats flashcards. Alright, so let's look at the first slide. It's not easy being random. It's not easy to just predict how a fair coin will land on any single toss. But if you flip it thousands of times, you're confident that you'd see 50% heads, so 500 heads. Choose a number 1, 2, 3, or 4. About 70% of people choose 3, 20% choose 2 or 4. It's not even fair. It's not even and fair. People use random numbers, called pseudo-random numbers, that are both equally and random. These are generated typically through your calculator or a computer. But on to the last point, computers have a finite number of values, so eventually these numbers repeat themselves. Even though they're not truly random, they're good enough to use. Alright, let's see an example. There's a cereal box manufacturer that puts pictures of famous athletes on cards in boxes of cereal in the hope of boosting sales. 20% of the boxes contain Tiger Woods, 30% a picture of David Beckham, and the rest Serena Williams. You want to get all three pictures. How many boxes of cereal do you expect to have to buy in order to get the completed set? Alright, so these are our possibilities for actually answering this. We could buy hundreds of boxes of cereal to see what might happen, or we can use a model to represent what would happen if we were to buy boxes of cereal. We need an imitation of the real process that we can manipulate and control. We are going to simulate reality, not like predict reality. This is a simulation. We want to understand the typical number of boxes to open, how that number varies, and the shape of the distribution. Because of this, we won't just try to complete a card collection once. We want to do this over and over. We call each time we obtain a simulated answer to our question a trial. Why are we doing a simulation anyway? It is hard to guess how many boxes we'd expect to open, whether it's 3 boxes to get the 3 cards we want, or 7,359, which is just a random number. A joke. Building a simulation. In this simulation, opening a 1 box is the basic building block of these trials, called the component of our simulation. We need to observe a sequence of components until our card collection is complete. The trial's outcome is called the response variable. For the simulation, this is the number of components boxes in the simulation in the sequence. Alright, here's the steps for building a simulation. Specify how to model a component outcome using equally likely random digits. Number 1. Identify the component to be repeated. The opening of a cereal box. 2. Explain how you will model the component's outcome. We will use the digits 0 through 9 because 20% of the boxes contain Tiger's pictures. We'll use 2 of the 10 digits to represent the outcome, 3 of the 10 digits to model 30% of the boxes with David Beckham, and the remaining 5 digits can represent the 50% of boxes with Serena. So basically, 0 and 1 are Tiger Woods, 2, 3, and 4 are David Beckham, and 5, 6, 7, 8, and 9 are Serena Williams. Alright. Number 3. Specifying how to simulate trials. Explain how you will combine the components to model a trial. So, to explain, we would say we pretend to open boxes until our collection is complete. We do this by looking at each random digit and indicating what picture it represents. We continue until we found all 3. And put it all together to run the simulation. 5. Run several trials. Consider this string of random digits. The first random digit, 8, means you get Serena's picture. The second digit, 9, means you get Serena's picture. We get Tiger's picture 0 on the third, Serena's 6 again on the fourth, and finally David Beckham's 4 in the fifth box. Now we found all 3 pictures. The trial outcome is 5 boxes. Run several trials such as these. Organize the trial by making a model. Number your trials. List your component outcomes by listing the random variables you've taken and match them with which picture you find in that box. Record your trial outcomes. Analyze the response variable. So for the 6th step, you would collect and summarize the result of all the trials. Summarize and display response variable. For number 7 in our steps is state your conclusion in the context of the question you wanted to answer. The best way to structure this is by saying based on this simulation, like that's very key. We estimate that customers hoping to complete their card collection will need to open a median of 5 boxes. Yeah, but it could take a lot more. Alright, so what can go wrong? Don't overstate your case. Simulations are not real. We do not really buy any cereal boxes. So, don't confuse what really happens with what a simulation suggests might happen. Model outcome chances accurately. Use a strategy that appears to produce the right results. Emphasize in your model that the outcomes are equally likely outcomes. And the third point, run enough trials. Don't try to draw conclusions based on just 5 to 10 trials. Use a large number of trials. And that is the end of my overview. Remember to go back and watch the videos posted on slide number 4. It's really helpful, and these videos will be up when I have them all uploaded to YouTube. Thank you for watching, and good luck.